Sorry about the slight delay on the AV stuff. It clearly takes more than a computer scientist to set up more than a screen. So you've come here to learn about how to write good, fast Python code. We're going to drill into that for a second. What does it mean? The reason I didn't just say, optimize Python was because I'd like to place equal emphasis on all those words. So what do I mean by good code? I'd like us to focus on writing code that's readable, that's understandable, that's tested, that's testable. That's always a bit tricky. Because we're not writing code for computers, we're writing code for other human beings we care about, our colleagues, or even ourselves in the future. I've often cursed myself for writing very, very clever code and then not being able to understand it 6 months later when I've just woken up. We'd like to write fast code within reason, right? I mean, there are lots of good reasons to use Python as a programming language. Its speed isn't necessarily the one that comes to mind, but that doesn't mean we can't write code in Python that's fast enough. And then finally, we'd like to write Python code, right? I presume you as well as me because you're here. We like writing Python code. I like writing Python code. I can write code in other languages. I can write C++. I write C# and Java if I get paid enough money for it. I'll even write VBA under duress. But to be honest, don't tell anybody else because I really like to avoid it. But we like to write Python code. Now, there's something about Python code that's just nicer than other code. You've kind of seen this once or twice today, so we probably don't need to go in that too much again. But, I'd like us to look at writing good, fast Python code. Well, that was my plan until about 4 o'clock yesterday. I've given this talk 2 or 3 times before. Yeah, I was hoping for a laugh there. I've given this talk 2 or 3 times before, and then I saw this tweet yesterday, and I thought, I'm doing it all wrong. So I basically skipped the cocktails, which I'm sure were lovely, and instead I went home and I completely rewrote my slides. So it's the first time you're seeing this. It's a world premiere. Welcome. Okay. So this flippant little tweet is actually really, really quite deep, right? Because C is always faster. Well, almost always. Okay, let's rephrase it. Reasonably well-written C is always faster than reasonably well-written Python. But of course, to achieve the same set of functionality in C takes an order of magnitude longer than achieving a set of functionality in Python. Well, it certainly takes me an order of magnitude longer in C or C++. And then, of course, in C, you'll probably have a stack overflow somewhere or a buffer overflow, and it'll be terrible. And of course, if I take this, I could flip this around as well, and I could say, well, yes, of course, C is going to be faster than Python if I have enough time to write it. But of course, hand-optimized assembler is going to be even faster than C, given I don't know. I keep on having conversations with mathematicians about the concept of infinite, and they keep on trying to tell me that there's different infinites and there's different sizes of infinite. Okay, so if C is faster than Python given an infinite amount of time, assembler is faster than C giving a larger infinite set amount of time, but it's clearly not practical. So if anybody hasn't seen this wonderful site, Computers Are Fast at github.io, I highly recommend that you have a look at this because A, it's a very interesting way to pass the time, and B, it's really, really useful to have kind of a concept of the order of magnitude of how fast your code could possibly run. And that's kind of what we want people to focus on. You kind of need to understand how fast a single computer can do something before you can actually focus very much on Python. and optimizing it. This is the other thing I want us to focus on. Programmers are really, really expensive. Look around you. You guys, you go to expensive conferences, you go to dinners, you want to get paid. Well, some of you, I guess, want to get paid. And you're not getting any cheaper, right? In fact, most of us, kind of as we get older, like to get a little bit more expensive, right? Computers, on the other hand, are getting cheaper and cheaper and cheaper and cheaper and cheaper. I remember back in the old days, when I first started in computers, I remember lusting after a Cray XC1, I think it was. It had this computer the size of half this room, and it had neon lights and freon cooling, and it was like the most amazing computer in the world, and it cost several $1 billion or something, I don't know. You can buy a Raspberry Pi today for, is it like 10 euros? That definitely has more memory and probably has more compute power than that computer from 40 years ago. So let us not focus too much on making things easier for the computer. Computers are cheap, we can always get more. Let us focus much more on optimizing things for us and for our colleagues. And this is a famous quote. Who has seen this quote before? Sorry, I need a glass of water. So, everybody knows Knuth. Knuth is the most famous computer scientist, I guess, ever. One of the few. Apart from Dijkstra, but nobody can pronounce Dijkstra's name. So, you know, this is so true. I spend so much time focusing on speeding up small parts of code. And most of the time it's completely pointless because it doesn't really matter. This is kind of the flow chart for this. So yes, if you're prematurely, or if you're optimizing, you're probably prematurely optimizing something that doesn't need optimizing. And you probably don't know until you've written a system about it. The other thing that's really worth, this is my first step towards a long-held ambition that I'm going to give a talk entirely composed of XKCD slides. Today is not that day, but it will come. So I have recently spent a day or two trying to optimize something in our quantitative library. And then I saw this XKCD when it came out. And I felt slightly depressed for a while because I'd spent a day or two shaving, I don't know, seconds of runtime off our processing tasks. Yeah, it's probably going to be recouped in the year 2227 if we're still running the same code. So that's very useful to know. So this is always something to bear in mind. And this is kind of what I was pondering last night while you were out enjoying yourself. When we're optimizing code, I think we have to ask ourselves a couple of questions. Well, first of all, we have to know, you know, you're saying, is it fast enough? Is it fast enough? That's not the question. The question you should ask yourself is, what is the definition of fast enough, right? What is your failing test? If you don't have a failing test, why are you changing code? So, until you have the failing test, don't even bother changing anything, right? If nobody complains that your code isn't fast enough, it's fast enough. Also, if you don't have unit tests, don't bother changing any code because you're going to get it wrong. Okay. Yeah, my speaker notes have disappeared. Now, let's assume that you have a failing unit test, or you have users that are complaining that things are too slow. Let's think about the ways. How can we actually make our Python code faster? There are a number of canonical ways. That's the first one. The fastest code you have is code that doesn't exist, right? Code that doesn't exist also has lots of other... Oh, I'm sorry. So the fastest code you have, code that doesn't exist. Code that doesn't exist has lots of other nice properties. It doesn't have any bugs. It doesn't need to be maintained. Anything else? It doesn't need to be tested. Code that doesn't exist and code that doesn't run is the best code you can have, right? There's a good friend of mine back in the UK called John Jagger who coined the phrase, less code, more software. And I'm a firm believer in that. So the first thing to do is do less. Now, sometimes you can't just not write code. That's fair enough. I mean, you actually have to do something occasionally. As we said, you know, if you're an expensive program and you want to get paid, it helps to actually do something on occasion. But do less kind of encapsulates a whole series of strategies for optimizing your Python code. The most important one is this one. Right? I have some of the most significant code level improvements in my runtime performance come from kind of these two lines. So in functools, which is a great module, if you haven't used functools before, use functools, it's interesting. There's an LRU cache. An LRU cache, for those of you who were fortunate enough to have an interesting degree rather than computer science, is simply a least recently used cache. It keeps last values around. And this can speed up your code tremendously. If you find this too complicated, in some situations you want to write your own, and that's a nice little exercise or a nice little kata you could do that's quite useful. But that's not the only thing we can do. To speed things up, we can get a faster worker. Now, in the past, that was kind of the default how to optimize your code strategy, right? This is the Microsoft Windows or the Microsoft Word approach to optimizing your code. You know, people are thinking, I don't know, Office 2003 is too slow. Well, I'll give them Office 2007. They have a faster computer. They'll run at exactly the same speed. These days, that strategy doesn't work anymore. That kind of was the strategy that sustained me from the beginning of my career in the 90s to now. And you could always just go and say, well, yeah, we just need to buy another computer. It'll be 10% faster. And that works. That's getting... Sorry, I need to stop moving. That's getting harder and harder because computers aren't getting faster and faster anymore. They're getting wider and wider, but the individual cores aren't getting faster and faster anymore. The other time this strategy kind of, people think this is a strategy is when you switch, say, oh, I can switch from CPython to PyPy or something else. That's a slightly different strategy. That's the strategy of avoiding overheads. There's a lot of overheads in CPython because it's a specific implementation. Kind of, well, okay, fair enough. PyPy is a combination between those two strategies. And now we're going to look at some actual code. Not a lot of it. It's quite early in the morning. Yeah. Okay, so this is my day job, right? So I've spent my entire career in finance, specifically looking at derivative calculations, working with quants and traders. And fundamentally, this is what I do, right? I write code that generates random numbers and calculates weighted averages of those random numbers, and then people make millions of pounds off this or lose them. I was at Lehman Brothers twice. If anybody can think back to 2007, it wasn't my fault, okay? Honestly. Okay, so this is kind of what I do. And this is, I guess, fairly bog standard Python, hopefully understandable to everybody in the room. It works. It works, it's great. Right. Now, I wrote myself a little context manager to run timings on this because that's the way it works on everything. Normally, if you're using IPython, you can just use %time or something. But this is kind of a nice little context manager. So I ran it this morning, and for 10,000 iterations of 10,000 random numbers, it took 209 seconds. Now, this is not great, right? This is kind of why people think Python is terribly slow. Because if you just, randomly, naively write Python, that's kind of what you end up with. Um, but yeah, there's a great solution here. If in so many situations, if you can just switch to this magical beast called PyPy, it will solve all your problems. I mean, just look at the performance improvement. From 209 seconds to 28, it's almost a factor of 10. If you can do that, great. That's my first recommendation. It'll save yourself so much time. You look like an absolute hero to your colleagues. Your boss will praise you. You will get a raise. Just switch to PyPy. Don't even tell people you switch to PyPy. Just suddenly switch out the binaries overnight. Nobody will know. Now, there's another strategy, and that's kind of what I do for a living normally. NumPy. So NumPy is a great way of cheating. So basically, I spend my day at the moment simulating power stations for financial, well, looking at power, squinting very hard, looking at a power station, squinting hard enough to make it look like an option, and then simulating it. And this is kind of what we do. And NumPy makes it possible for us to do in Python. We do this in pure Python, and it's actually a complete lie. No, we do this in highly optimized C++. It's just that it looks like Python to us. So this is my next recommendation. If you're doing numerics, use NumPy. Why? Well, if you're doing numerics, you probably are doing NumPy already. But this is a great tool. And that's even faster. And now I was going to go on to my next strategy. So if you can't get faster workers and you've exhausted the kind of avoiding overhead strategy, well, how else do you get more work done or get your work done more quickly? You need to get more workers. Now, we're really lucky in that, and now this is kind of a standard modern computer, modern-ish. You know, we've got 1, 2, 3, 4 cores in there. They're pretending to be 8, but really it's just 4. And so we can just do this. And this was supposed to be my killer slide for this morning, and I will give a prize to anyone who can find the obvious bug in there, because it didn't work this morning when I ran it. So, strategy, get more workers. If all else fails, if you've applied all these strategies and none of them work, now you have to get to the nitty-gritty. Do this, measure. We're really lucky. We're in Python. We have a Python profiler built in. Who here has used the Python profiler? Okay, shame on everybody else. It's even if you haven't used, even if your IDE is the ideal setup of just Vim and a command line, the Python profiler is trivially easy to use. If you're using modern IDE, just have a look through the menus. There'll be a profile option somewhere. Go and use it. One really good trick about the Python profiler is not just to look at the numbers, the timings. Some of the biggest insights I've gained from the profiler is actually looking at execution counts. So if you can't quite figure out why your program is taking so long, have a good look at the execution counts and then figure out why that little function that you never really thought about is being called 14 billion times, and track that down. That is a sort of secret top tip. And then this was what my talk about was the last 2 times I gave it. And I've kind of, if you really want to see this talk, grab me afterwards. I'll gladly take you through the slides and email them to you. I've deliberately not spent any time on this because of this, right? Micro-optimizations are the tar pit of the programmer. Don't do them, right? They're great fun. I mean, you can spend literally hours and days trying to, come up with a slightly better way of shaving a few nanoseconds of this in a loop. And it's really a complete and utter waste of your time and your boss's time, except on those few occasions when it actually matters. So instead, I'm going to suggest that we take this famous quote from Strunk and White. How am I doing for time? Okay, good. Okay. So 15. Okay. So Strunk and White are two Americans in the early 20th century who wrote a style manual, and it's one of my favorite style manuals because it's very short. And I'm a lazy person, I like short things to read. And what's even nicer about it, it basically can be boiled down to this. It's all about omitting needless words. I would therefore encourage you to omit needless code. Focus on making your code as readable and as understandable as possible to your colleagues and yourself, testing it, and enjoy XKCD. Now, this is it. As I said, if you want to see micro-optimizations, I can show them to you later. But instead, I'd much rather answer any questions you might have. Thank you.